Hello there and welcome to this week's edition of Engineering and You. It's a program where we seek to encourage secondary school students and younger to choose engineering as a profession that they would love to go into. Why? Because the development of any society is hinged basically on science, technology, engineering and mathematics. So that is where development comes about, and that is why the sponsor of this program, Prince Engineer James Shillon, FNSC, has decided to put his money here to encourage young people to go into the field of engineering. My name is Tunolaniro, and today this program is very interactive and it's going to be very interesting, as I must say. Very interactive one where we just don't get to talk to you, but you also have the opportunity of talking to us and having your say, so to speak, and win a prize courtesy of our sponsor, Prince Engineer James Shillon. What is our question for the day? Our question for the day says, which of the following materials has the highest conductivity? Which of the following materials has the highest conductivity? A, copper, B, gold, C, silver, and D, aluminium. So if you get the answer, just give us the option A, B, C, or D. If you get it correctly, you'll get a prize courtesy of our sponsor, Prince Engineer James Shillon, FNSC. You can also drop it on any of our social media platforms. We will rest assured that if you get it correctly, you get a prize from our sponsor. That is our question for the day. I will just take this very short break. When we return, my guest is seated. The topic he's going to be discussing with us, I'll let you know immediately after this break. That you are still there. The program is Engineering and You, sponsored by Prince Engineer James Shillon, FNSC. My guest for today is Dr. ABIODUN ISIAKA EGUNJOBI, and he's going to be discussing a very, like I said, very interesting topic with us, and that is implementation and benefits of simple electronics. Implementation and benefits of simple electronics. What is this all about? I would let Dr. EGUNJOBI do justice to it. But first of all, let me just say welcome to Engineering and You, sir.
Thank you very much.
All right, please go ahead on this topic, implementation and benefits of simple electronics.
Yes, thank you very much again. Simple electronics and physics are interwoven. Okay. Now, physics, I would like to start by mentioning one or two things about physics. Physics as a course is the study of the universe around us. That is the world around us. That is, what are those things that you can move around, things that you can touch, things that you can feel. So those are the things that we study in physics. Like I said, it is the science of the world around us. That is the universe, either in small quantity or in large quantity, as in objects that you can easily push around, touch, apply forces on them, apply energy on them, or probably move them from one point to another. Yeah, that's what we basically studied in physics. But for the younger ones, we do define physics as the study of matter and energy in relation to the world. That is, how does matter, with respect to energy, have effect on the world around us. Now, what do we call matter? Matter is any object that has mass and also occupy space. That is, you should have a mass you are talking about, then there should be a space it's going to occupy. Then you say this is a what? This is a matter. So, and then energy is simply defined as the ability to do work. That is, how much work can you do with a particular amount of energy. So I will just limit my definition of physics to that. Also, I try to separate physics into two aspects. I called one macro physics and I called the other one micro physics. Now, under this I group physics into different, the subject we study in physics into these two aspects. That is, the macro means what are the objects that you can easily, the objects that you can, that are macro in nature. That is, you can touch them, you can carry them, then you say they are macro objects. So when you study that, the aspect that we do study in that is probably classical mechanics, thermodynamics, fluid dynamics, electromagnetism, and so on and so forth. Those aspects are under macro. Then when you come to micro, that is object that you cannot touch, you can just feel them. That is a very small object. Then you go to quantum mechanics, you talk about particle physics, you talk about atomic physics, and so on and so forth, because of our limited time. So, as I said earlier, physics is what happens around us on a daily basis. You moving from one point to another, you have undergone a physical exercise. A car moving from Lagos to Abeokuta, it has undergone a plane moving around. So all those things are examples of what we see on a daily basis. And I said, throwing the ball around, riding a bike around, all those things are basically physical exercise. So physics deals with physical exercises that we can do, and what are the effects of energy and matter. Now, I want to now go into physics with electronics. How does physics now come into electronics? Now, I said the application of physical principles into the design, development, and operation of electronics of our systems. Now, what are these physical principles? Voltage, current, resistance, power, Ohm's law, all these listed quantities, they are referred to as physical principles. So what do you mean by voltage? Voltage is the potential difference between 2 points, between 2 point charges. That is, from one point, what is the potential difference? Likewise, current is the movement of electric charge from one point to another. The resistance, power is your ability to do work, Ohm's law, all those things, they are physical quantities that have effects on, because without all these principles that we're talking about, we cannot even achieve electronics work. They are the basic things, they are the guiding principles that bring about electronics. Now, you can see I have some electronics appliances there. I said television, phone, robotic, electronic circuits, microcontroller, sensor, all these things that are listed there, they are achieved via the principle of electronics. So, now, simple electronics projects, what did this actually mean? Simple electronics projects they are great for beginners and often involve basic components like breadboard, Arduino board, resistors, capacitors, LED. What we mean by LED is light emitting diodes, transistors, simple IC. IC means integrated circuits. Now, for the young ones, especially those that are very interested in electronics, this is where they can start from. Okay. Yes, they can really start from this, because by the time you start practicing what you are interested in, then you'll be able to move further. Now, I just want to discuss how a breadboard is being used. These are things that you can easily do at home, even at your leisure time. Not even because the danger attached to it is minimal. There is no danger because it's just, we're talking about 5 volts appliances. So there's nothing like even this thing there will be an electric shock or anything. No. So if somebody have seen this sale in the children, there are some small things that you can get for them. They will do it and be excited. They will say, so I can do this. I can put this together and I will achieve this. So, but basically, this breadboard that we have there is meant to add 1 or 2 components together and see the effects and see whether it's going to work or not. Now, you can see there's a red line, there are blue lines, there are all those lines, then there are. So we have the linear parts, or what I can call the horizontal parts, and the vertical parts. So if you want to connect a particular component, you must learn how to use this breadboard because there are wires under it. So these wires are linked linearly, some are linked vertically. So you should know that which one am I going to put this. So further knowledge will guide you. And if you want to confirm that, which I have just said, just remove the insulating parts of the breadboard at the back. You will see the way the lines, the wires are being done. So that will guide you on how to use it. Because in electronics, you don't link two legs together for no reasons. So if you are having a resistor now, you cannot put the two legs of the resistor on the same wire. Definitely you must use the other leg somewhere else. Yeah. So that breadboard, we use it basically in the laboratory to guide the students, to explain things to them. But when it's moved more advanced, then you go to what we call variable. In that case, you need to start soldering. So because you are trying to move towards a finished goods. But with studying in the laboratory, the breadboard is fine for the student. Now we have the other components, the resistors. I said we have something we call integrated circuit. That integrated circuit, that is an IC. It's like you're having so many things inputted into a single device. And an IC is going to contain a particular circuit in which you have just tried to maximize your space and integrate it into a single device. So that is an IC for us. Now,
resistor.
Yes.
You're talking about resistor.
Yeah, I've spoken about the resistor. I want to move further. Now, for the new generation and the upcoming pupils or students that may be interested in going deep into electronics, this Arduino board that we have on the board is very, very good for use, because basically everything that you want to you need to learn with more energy, this will solve it for you. Okay. It is an integrated device whereby you just have to have a small code in addition to this board, and the code will be run on the device. And that board, as it is, there are so many homework that can be done with it. Just having the board, go online, see what you wish to do. Probably you want to design a flashlight, a blinker light. Just get 2 or 3 more components with this board, and you are done. The code you're going to use, we call it a C or C++ code. Those codes are already online in case you are interested. So you just get the code, run the code onto the Arduino, and you'll be amazed when you see your device functioning. So that is about our Arduino board. Now I try to bring up some projects that can easily be implemented by the school leavers or secondary school pupils. These are some of them. We have I said we have a LED blink. Now all you need to use for this LED blink is getting the Arduino board, as I have said earlier, the LED light that we call LED, which is a light emitting diode. Just get a single one, the breadboard will be there, then the jumper wires. Now by the time you try to put this thing together on your own, you'll be amazed and you'll be surprised that so all these things are as simple as this. You can also design what we call a traffic light. You time it. You use what we call a timer. You arrange it in a way that when one is going, another one will stop, this and that. So those things are simple things that our students, our children can easily, immediately you see them having the skill to do things like this, there are things that they can even be doing in your present and you'll be amazed. So we have light sensors. That one involves using the Arduino board again. You have the photoresistor, we have the breadboard. You can see most of them involve the Arduino board, resistors, then the breadboard, just because we are trying to practice and see what's going to happen. I said temperature and humidity monitoring device. They involve this DHT11 is a sensor which will sense the environment, and you will see the difference that this is the temperature now. Then we have a servo control in which you'll be able to. I was discussing with a young fellow like this too, and a young boy, that you can design a car with just about 15,000 naira. A moving vehicle that you can. He said, no, I said, okay, get this. try and put them together, and you see that your device will move from one point to another. He said, is it possible? I said, yes. They need to go and look for carton and start wasting your time. So those are the things that can really motivate the students to get involved, because I see that nowadays the advanced world, they are more interested in what you can do with your hand, that we call the hands-on. So it will be encouraging, to make more sense to encourage our pupils to do things with their hands, when they will see the results and they will be enticed. So then we now have some skill development requirements. That is, you have to be competent with circuit analysis and design. Circuit analysis and design, that is, you want to do something, you should be able to use your pencil or your biro to add one or two things together, which can, if you need assistance, I believe the teachers or whoever is available can assist. So you should be able to put on some simple design and so on and so forth. Then, as I said, the programming and coding, these ones are already something that are available free online, especially as you are using an Arduino. So Arduino codes are always free online. So career opportunities, that is even so many. So you are very good in electronics. I can tell you, you can stand on your own and you'll be doing things that are very, very interesting. So you can be an electronics engineer. You can get a job as an engineer. You can get a job as a robotic engineer, renewable engineer, technician. All these solar panels, solar installations, they are all they are all part of the electronics. Then you can also, these medical devices and that we use, scanning, electron microscope, all these SEM machines, all these EGEC machines that are used in the hospital, they are things that somebody that is conversant in electronics can go into. Then I want to mention some benefits of learning electronics. Now, you'll be an expert in hands-on learning. Yes, hands-on. That is, you can lay your hand on something and find a solution to it easily, because you wouldn't want to stop what you are doing if you have not achieved your set goal. So you can be an expert in hands-on. Then you can be an entrepreneur into opportunities. That is, you can either be an employer of labor if you are as good as necessary, because from experience, I've seen one or two students that by now, after their secondary school, with what they have learned so far, they were able to stand on their own and implement one or two things. You'll be surprised that you are able to achieve those things. So, you can also improve. You can have enhanced career opportunities. Yeah, your career opportunities can be, because that will add to your CV that this person, apart from being an electrical engineer, you can also put. It's not a matter of you just being an engineer alone. Then can you also go to the lab and do something with your hands? Apart from the book you have, the theories you have learned, can you also use your hand to do something? And I think that is what is very, very important in engineering discipline. Then economic benefits are there. It will enhance your cognitive thinking. That is, you'll be able to think fast and think better. Then interdisciplinary applications, and so on and so forth. All those things are benefit of learning electronics if you really show a good interest in learning. So I would like to stop there for now.
Okay.
Yeah. Thank you.
Thank you so much, Dr. EGUNJOBI. One thing you did today, yes, for us, especially for our young viewers, is, yes, that you just made physics look practicable.
Yes, very, very practicable.
Because most of the time you see in our schools, you just do this parallel resistance, and you don't know. You're just doing the calculations.
The calculations. When I was invited for this program, I have it in mind that if there is an opportunity for secondary schools to have workshop within the school, if the government can do that, let these students. From my experience, out of about 20-30 students, 1 or 2 will be totally interested in that thing. And if you can encourage such a person, because of one person, you can put 100 people in a particular occasion, and the person that will be interested will just be one person, and that person will achieve his or her aim. So I believe in what you can do with your hand, because the way Nigeria is going on, my brother, is what can you do with your hand, because the white collar job is nowhere to be found as usual. So I will encourage the younger ones to please learn what they can do with their hand, especially when it comes to electronics. Electronics is very interesting. If you are interested, you just start developing your interest and you achieve your aims.
Okay, are there some misconceptions when it comes to electronics that you would like to clarify?
The misconception is what I partially mentioned initially. The fear of what will happen to me if I try to hold this. Will I get shocked? Will I do this? Will I that? So that could be the fear. Then two, in electronics, when we work in electronics, we will tell somebody that wants to do the work that come. You don't buy one component if you are working on electronics. If you want to produce this phone, and you need 2 or 3 resistors, you buy 6. Because along the line, while you are doing the work, one may get damaged because you are just trying to troubleshoot. So you have to replace it again and put another one. So those are the fear people do have. Probably the money they are going to spend. Then two, the fear of what of if I get electric shock, all those stuff are there. But if you are careful enough, then I don't think there is any problem.
So as we coast home now, I want you to advise that young man, that young girl, because we have women too in engineering,
definitely,
that you have stirred up their interests, all those calculations, Ohm's law and all of that. You have made them understand that it's not in vain.
It doesn't end there. Yes.
Now, how do you encourage them now to make sure that, see, if you want to, these are, for example, the courses you have to do if you want to be an electronic engineer or a robotic engineer. These are the courses you should select, even at secondary school and at JAM level.
Yes, for WAEC exams. So if you are a science student, definitely you know that you have to pass the 5 basic science courses, which is English, mathematics, physics, chemistry, and biology. That is compulsory for science students. Either you want to study engineering, you want to study pure sciences like biology, physics, chemistry, or you want to study anything you want to study in science. You should have those 5 basic courses at the WAEC level. So then JAM, you now have to move to a particular area. It's either you drop biology for engineering, then you drop physics for those that want to study medicine and so on. So if you are doing, if you want to study engineering and you want to do JAM, you have to do English, physics, chemistry, and mathematics. Mathematics is very compulsory for any engineering course. Then, but if you are to study biology-related courses, you drop that mathematics for biology, and that's, you are good to go.
All right, we are good to go, and that's our cue for today, because we are actually good to go to leave the studio because our time is up. I want to say a big thank you to Dr. Engineer Dr. ABIODUN ISIAKA EGUNJOBI. Thank you so much for making physics look simple, and thank you for coming.
Thank you very much.
I want to say a big thank you to you also for being there. Our question for the week says, is on the screen already. Okay, that's our answer for the question for the day. Our question for the week says, what is the process by which water moves through a plant from the roots to the leaf? If you know the answer, please just drop it on our social media handles. Next week we'll announce you if you are the winner. And we have to go now. Thank you so much for being there. Thank you for watching. Thank you to our sponsor, Prince Engineer Mrs. Shilon, FNSC, for doing this every week. Until next week, my name is Tunyola Niro. See you then.